Problem 53 from chapter 26. A beam contains 4.5 multiply 10 power 8 doubly charged negative ions per cubic centimeter, all of which are moving north with a speed of 300 meters per second. Here we have three questions. The first question is, what is the magnitude of the current density J? And the second question is, what is the direction of the current density? And the third question is, if the particle distribution is uniform across the cross-sectional area of 2.5 micrometer square, what is the current? So we have to answer for these three questions. Let's rewrite the given first. So what is given in the question? The number of charge carriers is given, n, which is equal to 4.5 multiply 10 power 8 per cubic centimeter. Clear? Cubic centimeter. So we have to convert this cubic centimeter to cubic meter. As we already know, 1 cubic centimeter is equal to 10 to the power of minus 6 cubic meter. By that we will cancel this centimeter cube with this cubic centimeter. Finally, we will get the answer in terms of per cubic meter. So here we got the answer as 4.5 multiply 10 power 14 cubic meter. Clear? Now, the most important thing, they clearly mention it is a doubly charge. So what is the value of the charge? As we already know, the value of the charge Q, which is equal to 1.6 multiply 10 power minus 19 coulomb, right? But they mention this is the doubly charge. That means we have to multiply this number with 2. By that, the charge takes the value of 3.2 multiply 10 power minus 19 coulomb. Clear? And also, they gave the information about the drift speed of an electron. So the drift speed V of d, which is equal to 300 meter per second. And the cross-sectional area is given, A is equal to 2.5 micrometer square. So we have to write the value in terms of meter square. So the micro takes the value of 10 to the power of minus 6. So therefore 2.5 multiply 10 power minus 6 meter square. In the first question, we are going to find what is the current density. By using all these values, we are going to find the current density. So I'm going to solve here. The first question, the current density formula, we already know. We have two formulas for the current density. Current density J, which is equal to I over A, current over area. And also, we have the equation for the current density J, which is equal to number of charge carriers multiplied by the charge of the electron multiplied with the drift speed. So here, this equation is not possible for this question. So I'm going to use this equation for finding the current density. So J is equal to, the charge carrier's value is given here as 4.5 multiply 10 power plus 14. And this charge is the doubly charge. So I have to use this value multiply with 3.2 multiply 10 power minus 19 multiply with the drift speed of an electron, which is 300 meter per second. So here I got the answer for the first question, J, which is equal to 0.0432, and the unit for the current density is ampere per meter square. So this is the answer for the first question. Now we have to answer for the second question. The second question, they asked about the direction of the current density. So we already studied this information in the theory. The particles here they mention is a negatively charged, right? So the current density should be in the opposite direction, or you can write its direction is towards south. Why? Because the particles are negatively charged. Therefore, the current density is in the opposite direction. So this is the answer for the second question. And in the third question, they ask if the distribution is uniform, right? So what they ask in the third question, if the particle distribution is uniform across the cross-sectional area of 2.5 micrometer square, what is the current? So here I'm going to use the first equations, J, which is equal to I over area. Clear? The current divided by area. I'm going to use that equation for the third question. So third question C, J, which is equal to the current over the cross-sectional area. And here we are going to find the answer for the current. So you have to rearrange this equation. So current I, which is equal to the current density multiplied by the cross-sectional area. And this current density value, I am going to take it from the first part. What is your first answer? Here we already find the answer for the current density as 0.0432. I'm going to use that value here. So I is equal to 0.0432 multiply with 2.5 micrometer square. So 2.5 multiply 10 power minus 6, and I got the answer for the current I is equal to 1.08 multiply 10 power minus 7 ampere. So this is the answer for the third question.